Good afternoon. How are you? No, not tired yet about presentations and PowerPoints and. All right. Thank you, Andreas, for the introduction. I don't know if it's an advantage of spending almost 28 years in the working for the automotive sector, but I'm very glad to be with you today to talk about one of our favorite topics, ADAS, autonomous driving. By the way, if you want to know more about us, we are also having a booth, and also interesting to visit the booth of our partner, AV Simulation and UTAC, and I will explain what are we doing together. All right, so we're here for the third time, and at least myself, attending this conference. By the way, thank you for the organization. I think it's very focused. You are always sure going to this conference to meet people who are, working on this specific topic about driving simulator, ADAS, autonomous driving. So it's always a pleasure to come, to hear, and also to meet experts. All right, the content I prepared today, sharing our thoughts about trends, giving a few insight about where we think we should put priorities to develop safe by design, ADAS and autonomous driving, and sharing a bit about our solution and where we did progress since 1 year. First, before going to the trends, I don't want to do any marketing here, but just in 30 seconds, if you don't know Dassault system, our motivation is to really develop solutions to help our clients developing virtual twins, but not only for the usage of the product in operation, but since the creation, since the inception of the products. And you may know that in the early days of Dassault system, our core topics was mechanical, but since now we are talking about a lot about innovation driven by software, electronics, we are very much looking at the overall systems, which I thought that the people who gave the name Dassault system to the company were really visionary at that time. I already showed you that picture last year. I love it because I had a Renault 5 in my when I was having just my driving license, and the evolution of the product in terms of HMI clusters completely changed, and especially not only now we are talking about connected products or highly automated products, we are talking more and more about software-defined vehicles. And what does it mean? It means that it's not only a change about the product itself, but of course many things are driven by software. And now car makers' trend is to decouple the software and hardware platform, because not only the car is becoming upgradable, but you can develop the entire software platform for a car maker. And of course, I'm starting with that because we identified that trend as one of the major trends overall for the system development for car makers, but especially for ADAS. So what are the key challenges then? To develop this ADAS on a service-oriented software architecture. So the capacity to define the overall system of the vehicle on-board, off-board is critical. The fact that, of course, following state-of-the-art practice like ASPICE, to make sure we master the definition at system level and software level. To take care about the regulation, and here we have, we want to bring dedicated solution for functional safety, SOTIF, cyber security, or software over the air. And of course, the capacity again to make sure we master the product development on the end-to-end cycle with an agile approach. So the strategy, so we are a scientific company, so every time people are thinking about the next vision, we're always trying to find what is a mathematical definition of this vision. So a few research people came out with formulas, but I will not go into detail of this, but what we are trying to say here is that we think that the distance between the physical, the real world, and the virtual world is going to diminish. And what we want with the virtual twin is to show that at every step of the definition, from the very early concept stage to the operation and the usage in operation, we are going to go from mission to experience as lived with cyber system, reducing the distance between virtual and real. So now, if we go to a little bit pragmatic pictures, everybody is looking at developing ADAS along the V model, right? So I will not debate whether the V model is still a good one or not, but if we stick with that one, the first thing we want to do is to adopt an agile multidiscipline model-based system driven for modeling and simulation. So usually people tend to model on the left part of the V and simulate and verify and validate on the second part of the V. And what we are trying to do at Dassault System and also with our partner AVS is to make sure that on the left part, as early as possible in the early definition stage, we can model and simulate at the same time with model in the loop, hardware in the loop, driver in the loop. And for this, it means that we need to start from the mission, the requirement with a global governance, a very robust model-based system engineering definition, requirement, functional, logical. And then the link with the disciplines. And the disciplines could be hardware disciplines and, of course, software disciplines. And so the overall goal is really to have a continuous development along that V model. And I will show you a few illustrations of that. So when you try to adopt this end-to-end approach, you need to care about many different users, many different experts. And the first thing we did is to develop a platform. We call it 3D Expanse platform, on which every single user can see the same thing. We call it a single version of truth. And make sure that we can break the silos by bringing all these disciplines together. So it's true at system level for the software-defined vehicle platform, portfolio management, mission definition, functional architecture, logical architecture, physical architecture. So that mainly for the system architect, for the requirement engineers. The subsystem definition with, again, requirement and test, electrical, ECU, physical architecture, and then at the component level. And then here, so this architecture and portfolio is valid, by the way, not only for ADAS, but for every single system definition of the vehicles. But especially for ADAS, we are partnering with AV Simulation, with the solution CATIA scanner, in order to complement what we have to do specific ADAS simulation, but again, linked to the platform. So let's go a little bit in detail. This chart is a bit complex, but very easy to understand here. I'm trying to put the different boxes of the overall solution architecture, right? Because there will be many people involved in the overall story. And what we want to make sure is that, again, we provide an environment where the different users can share the same level of data across the development process. So starting on the left side, with all the system analysts, people working on the overall simulation, to ensure the full traceability. Then requirement levels. So we did a lot of experiment on requirements, modeling, and simulation. Especially, we found out that a lot of people are talking about model in the loop, software in the loop, drive in the loop, of course. But we think that we could start with requirement in the loop simulation. What does it mean? It means that with solutions like Stimulus, you can already analyze the semantic of the requirement definition, and you can already detect a lot of mistakes. As a matter of fact, a lot of studies show that almost 70% of the errors in the development of the ADAS software are made since the requirement definition. So this is why we are investing a lot on that. Then we do mobility system architecture and vehicle system architecture with CATIA Magic. For some of you, you may know that we acquired a company called NoMagic, which is a leader in SysML definition. And why we think it's important for ADAS? Because we think that there is a lot of things that are actually modeled by the system architects that would be the primary input then to set up the simulation environment for the ADAS definition. Then EE architecture, software and architecture, and again for everything related to integration, simulation, and test. For the ADAS testing and simulation, here we rely on CATIA scanner from AV simulation. It does not appear in the slide, but we want also to make sure that different partners, different solutions can be integrated in the platform. So this platform is open. And this is why, for instance, the CATIA Magic solution, but also CATIA scanner is integrated in the platform. So what kind of questions do we want to answer with our CATIA Cyber System solution and CATIA scanner? The optimization of sensor position, the vehicle dynamics, the management of the simulation of results, the possible training of algorithm for car makers, safety critical software, ODD, regulation. So that are the different questions that we want to address. And we want to make sure that we bring the value of the complete chain, meaning looking at the sensors, the V2X communication, HMR, HMI, driving monitoring system, ECU, of course, actuation, but also the overall layer, potentially of artificial intelligence, machine learning. So we want to bring values with the solution on the different aspect of ADAS development. So here is a few examples that we have been doing with different car makers through the year. For example, in the ideation phase, the test of new technology with machine learning, on concept architectural design, traffic jam chauffeur, design with CATIA Magic. So again, we are more on the system architecture phase here. Then if we go to architecture trade-off, for example, with lane keeping assist, also adaptive cruise control, and also emergency braking system. So these are the different use cases that we are currently exploring, and again, trying to reduce the distance between the virtual simulation and the real test data. I just would like to show you an illustration of what we are doing on a simple scenario, starting from the mission definition, architecture, simulation, traceability, and correlation. So this is a very short illustration, but again, you can meet our expert at the booth if you want to know more. So here you are in the platform. The first thing is to master the requirements definition. So here we are looking at consumer kind of requirements, regulation, but could also be a description of the ODD, the operational design domain. And very quickly, you can make this data completely integrated in different models, which has been modeled with CATIA Magic here. So you see a couple of use cases. Then you're going to see ECU model, sequence diagram, and everything can be simulated with behavior, so logical behavior within CATIA Magic, or you can directly simulate in with CATIA Scanner the same logic, but with all the different software behavior inside the vehicles. So this environment, again, has the aim to be used as early as possible in the development of the overall ADAS in order to make sure that you can detect error as early as possible. You can see also that we have integration of Euro NCAP scenarios directly embedded into CATIA Scanner with another partner, UTAC, at the booth with us. And this brings a lot of expertise of the solution around the UTAC scenarios and the capacity to get this scenario directly integrated into our applications. So this scenario content within the platform is crucial in order to make sure that we can get the direct access to the regulation. Of course, one of the things also that we aim is to make sure that we then propose a complete way to manage the test associated to that will be run into CATIA Scanner in the platform. And the first thing is to be able to navigate into the test within the platform, to visualize them in order to make sure that we can debrief about the different results and compare and make for example, run some design of experiment to make the best trade-off. And also, again, to make sure that the people who are actually analyzing the different simulation can have a dialogue with the people designing the architecture in order to make sure that you get the right collaboration. And again, everything shown here is part of our latest platform development which is available on-premise and on the cloud. So the goal here is to propose this platform to car makers, tier 1 suppliers, and engineering partners who are developing ADAS simulation. So last year you had a beautiful illustration from Renault and Olivier Colmar and Didier Vautier, which is still a very strong partner of us. By the way, I was very impressed about also the physical simulator that they put in place in France, which is very impressive in terms of capacity to put a real driver in the simulator and to simulate the overall ADAS. And again, this simulator was designed also with our partner AVS. On another things, there is a parallel session with BMW and our Dassault system colleague doing simulation SIMPAC for Multibody Dynamics. This specific application is also to bring a higher accuracy in the dynamic of the vehicle for driving simulator. So this is also a technology that we have at Dassault System as part of our simulation portfolio. And the goal here, because is to make sure that in the future, and this is already work in progress, we build an interface between this kind of multi-body dynamic solver like SIMPAC together with CATIA Scanner in order to bring a higher level of accuracy in the simulation of ADAS on the real-time simulation. All right, and just to conclude, I would like to say that this is a long-term commitment of Dassault system for the ADAS and autonomous driving topics. From day one, we decided to go with partner, again, AV simulation, developing scanner, which is now CATIA scanner in our platform, UTAC, bringing the expertise of the actual regulation, especially NCAP, and providing scenario directly linked to our solution. And we are also, and you remember last year we did a communication with Capgemini. We are having also a key partnership with engineering service company in order to bring also the capacity to get real data coming from the field in order to give a feedback loop to engineering. So if you want to know more and discuss with our experts, we'll be very pleased to do so. And I'm here tonight with you at the cocktail, so if you want to have any one-on-one discussion, I will be very pleased to share some thoughts with you. Thank you very much.